Hello and welcome to Software Architecture course. In this lecture, we will be studying another important pattern, which is called the reflection pattern, which is a part of adaptable systems. So let's look at what the basic idea is. The basic idea is that the reflection pattern is actually used very often today and it is there in most of the programming languages. But this reflection pattern was developed and defined much earlier. So the idea is that the reflection pattern actually allows a runtime discovery of different interfaces and dynamic calling of many discovered interfaces. So essentially the idea is that when it started, of course, that time the main idea was that if I have an object which is going to offer certain services, at runtime the client will be able to discover what are the interfaces that this object actually exposes, and then based on the interfaces that it has discovered, it can make a call. So just like any other pattern, let's look at the context and the problem. The context is that one should be able to support for variation and change in the structure of the system, and it should have an architecture that's open to change. That's a requirement. Question is that how do you build such a system where the changes that might come are not really anticipated earlier? So the solution is this reflection pattern, and the reflection pattern essentially what it does is it encapsulates information about various properties and various aspects of the application structure, its behavior and a state into a set of meta objects. So you can imagine that this reflection pattern to be basically a two-layered architecture, or a layered architecture having two layers. The one which is at the base level, or the layer which is at the bottom, that actually contains the application logic. On top of that there are set of objects which are called meta objects that contains various meta level information. And very important part is that application logic and the meta object information are separated out. So today, again I'm repeating that today the reflection pattern is quite heavily used in many programming languages, many object-oriented programming languages and even scripting languages. But the pattern is more generic, and that can be, one can always design their own reflection mechanism, just the way today modern programming languages like Java, C#, etc. have designed. If needed, you can also design your own reflection pattern. So the basic idea is that when you want to design the reflection pattern, you need to basically create two-layered architecture where at the bottom you have this application logic, and then at the top you have the meta objects that contain information about the application structure. Now if you want to basically create a system where your application is very adaptable, and it can basically manage any kind of change which is unanticipated, then the design should be that at the base level the objects always consult the appropriate meta level object which is at the top before executing its behavior. In fact, if it is done that way, then essentially the relationship between applications, the kind of methods that are called, the kind of interaction that happens between objects, they're not hard-coded. They become very they're all dependent on the meta object. We will see some examples which will clarify this idea. Examples are the Java actually offers a reflection through its capabilities provided in Java Reflection API. Broker pattern like Corba, RMI. In fact, Corba is the first distributed system in which this reflection mechanism was introduced. So what Corba did was it offered the reflection in terms of dynamic invocation of the interface. It actually maintains an interface repository, and from the interface repository the Corba infrastructure would be able to query and get the related information about the interface, and then it can make a call. In other words, when the client wants to use such a reflection mechanism, it first queries the interface repository to get what are the interfaces that are available, gets the interface as a meta object, and then invokes the appropriate method. RMI is basically influenced by this CORBA pattern, and in fact RMI is called remote method in interface. That's a part of Java, and it came even before Java Reflection, or rather it was there at the same time when Java Reflection, very primitive version of Java Reflection was there. But inside RMI, the implementation actually was heavily influenced by this CORBA design. So let's look at the CORBA reflection pattern. This is an example. As I said, the basic functionality of CORBA basically supports so-called a dynamic invocation interface, and it is a client who basically can use this dynamic invocation interface to understand the capability of the server and then invoke the appropriate service. So the service description is actually present in a dynamic invocation interface. Now it actually follows a classic reflection pattern having two layers. Remember that there is a meta layer and there is a base layer. So CORBA interface repository is essentially the meta layer, and it is implemented as another CORBA object that actually stores the content of IDL and different types. So just the way a client would invoke a server object's capability, just the way the client gets a handle to the server object and then makes a method call to the server object, exactly the same manner it first gets this particular CORBA object, which basically models the interface repository, and it invokes certain methods. The methods that it invokes are predefined, and these are all supplied by the CORBA infrastructure. So these methods would return the information about the actual server, the methods that are implemented, and so on. Remember that if you are using a CORBA infrastructure and you are using a product that has implemented CORBA, then, and if of course that product supports DII, in early days of course not many products supported, but later on almost every CORBA compliant middleware supports DII. So during that time, when you basically get, when the client first gets the interface repository object, makes a method call, that method call actually returns the type of servers that are there, the methods that the server actually can support, and so on, and then client can basically look at that server, the methods, and then make the method call. But what I was telling is that this whole infrastructure is completely transparent to even the server designer, where the server designer, the developer who implements the server, basically creates the server IDL, compiles it, and this interface repository, etc., is automatically created when the IDL is compiled. So when in other words, when this server is compiled and then server is created, the CORBA interface repository is also created. So user don't have to do anything for that. So once this IDL type is added to the repository, then anybody can query the repository at runtime. Essentially, as I said, it can dynamically understand an interface and makes call onto it. It can dynamically manipulate an interface by adding or deleting interface methods, and so on. So let's look at another implementation, which is RMI, and look at the how reflection is implemented there. So RMI is sans Java remote method invocation. That is also based on the broker variant. It's also another type of broker. As I said earlier, it is influenced by CORBA's design pattern, CORBA's design. So the implementation will be quite similar. Since Java, Java, when the language is designed right from the beginning, it started introducing this reflection as a part of JDK. So Java reflection is actually used to determine the properties, events, and methods, and that's basically used to implement this remote method invocation. In fact, this reflection is also used while transmitting an object from client to server. So here we are talking about a remote method where client is on one machine and the server is in another machine, and suppose that the client wants to make a call to a server and it wants to pass an object. So what the infrastructure would do is that the object that is to be passed is first serialized. So after serialized, so the serialized object as a stream of binary data is basically passed from client to the server, and the server then deserialize it to reconstruct the object. Point is that this serialization mechanism where the object which is in memory is basically created, is basically converted to a file, a binary file. This process of creating, this process of dumping the memory content into the serialized object, this process heavily uses the Java reflection mechanism. In other words, it basically queries what type of object it is, what are the properties, what are the methods, what are the properties, so different class variables. So all this information is obtained from the Java reflection, and that information is basically stored as a serialized object. Let's look at the Java reflection mechanism in more detail. So Java, this reflection is not only used in RMI, but it's also used even in Java Beans. And if you remember RMI, after RMI, then eventually this Enterprise Edition J2EE, Java Enterprise Edition or Java based middleware came into picture, where the servers are actually implemented, or the server part was actually implemented as Enterprise Java Beans. Not just that, even at the client level, when you are basically modeling a data value, that data value was implemented as a simple Java Bean. So simple Java Bean basically has a set of properties. You can imagine that it's a kind of a C or C++ structure having a set of fields, but important part is that these fields has something called an accessor method, get and set. Now this get and set, so in Java Beans what happens is that these get and set methods are automatically created by the framework, and this automatic creation of those get and set methods based on what are the properties. So this mechanism of creation is actually using Java reflection mechanism. Using Java reflection, one knows what are the properties, and then it can accordingly create additional methods. So reflection is used by Java Beans to determine various properties, events, and methods that are supported by a particular bean. Now in Java, the main entry point or the main information starts with java.lang.class. That's the entry point. From this entry point, you will have this if you look at java.lang.class, you will find there are methods which are essentially reflection type methods. How is Java reflection used? So in practice today, Java reflection is used in many other scenarios, not just RMI or object serialization. Example is JUnit. JUnit is essentially a unit test framework. So this JUnit framework, it uses reflection mechanism, and it uses that to parse this annotation called @test. Remember, this @test is basically a style in which it's a style of defining an annotation in Java. So JUnit the unit test framework, what it expects is that inside your class you not only have simple methods but also unit test methods, and for that you need to basically annotate those methods using @test. Now JUnit would be using the reflection mechanism to find out where are these annotations present, and then it can basically get those methods which are basically meant for unit testing, and JUnit can invoke it. The Spring framework, it uses something called an injection of dependencies, and this is used at the client level essentially, which is again meant for things like building the UI infrastructure. So this whole web-based development where there are web pages and web pages, from one web page you move to the next web page and so on, and the whole control flow of these web pages, using the data to store the information about the web pages and so on. These are typically implemented by the Spring framework. It uses something called a dependency injection. This uses internally the reflection mechanism. I'm not going to cover dependency injection in this course, but I would strongly recommend that you read what is Spring dependency injection in more detail, and you will appreciate that this dependency injection mechanism also uses reflection. Tomcat web container. Tomcat is a very popular open source web server cum web container, which can be used to implement a simple web-based application. So what it does is it basically parses web.xml file and the request URI to basically understand what object and what method of that object need to be called, and then it forwards the request to the correct module. So web.xml is the XML file containing the information about the class that need to be called for a given event. So depending on the URI that is received by Tomcat, it goes and analyzes web.xml file and then picks up the right class, right method, which is stored in XML file as a string, and then by reading this using a reflection mechanism, it invokes the correct module. Eclipse is an IDE or intelligent development environment in which today people basically build their Java projects, C++ projects, Perl projects, and so on. Eclipse also uses auto-completion feature of method names. In fact, if you look at Microsoft version of development environment called VSTS or Visual Studio, that also uses the same thing, where for a given class it can tell you what are the available methods. You can choose that. All these are done by and this feature is called auto completion. Well, this is implemented using Java reflection mechanism. Struts framework, it also uses Java reflection. Hibernate, which is basically helps you in storing the objects into database, or this is also called object relational mapping framework. This also uses Java reflection to understand the structure of an object and then basically stores that information into the database. We'll continue with Java reflection and some more features. So the Java reflection today supports this querying of information about a particular class, method, package, etc. at different levels. The topmost level is called at the class level. So at the class level, this reflection framework or the reflection mechanism will give you features to get information about a class. What is its superclass? What are the members of the class? What are different packages? What are the modifiers, different methods? What are the different interfaces, and so on. At the field level, it can give you different types of fields that this class is using, get set information, and so on. Method and the constructor level, it basically gives you information about what are the public methods, what are the access specifiers, what are the constructors, then what are the parameters of this method. Not just that, it can also help you in invoking the method. So you can query what are the public methods, you can search their names, and then you can invoke the method. For the constructor, it can search for the right constructor, and it can actually create an object by calling that constructor. then it allows the reflection at the annotation level. One example I gave already, which is used by JUnit. So the power of Java reflection, let us look at it. The power of Java reflection is that it can support so many features, and let's look at each of them. Example is that it can load a class dynamically, of course, and that you have seen if you have done good amount of Java programming. You know, one example that comes into my mind right now is JDBC, where you are loading a driver class dynamically. You are looking for if particular driver class is present in the system or not, if it has been linked, and then if it is linked, then it can load that class at runtime. It can determine whether it is a class or if it is an interface. It can determine for a given class what are its superclass, what is its superclass, and what are the interfaces that with this particular class implements. It can instantiate a new instance of a class. It can determine the instance methods. It can invoke different class and instance methods. It can manipulate fields. It can determine different modifiers for the fields, methods, classes, and interfaces. So let's look at class and interface example actually. So let's look at how it can load a class. So it can do like this: class C equal to class.forName, and then give the name of the class as a string. It can load load the class. It can check C.isInterface. It returns true or false. It can check whether it can actually retrieve its superclass. For example, class C1 equal to C.get superclass. It can also get different types of interfaces. Like for example, it can return C.get interfaces. Remember that in Java only single inheritance is allowed, but it can actually support multiple interfaces. So class C2 equal to class array of classes C2 equal to C.get interfaces, that would return a set of interfaces that this particular class C implements. So let's continue with that example. Determine the constructor C. So it can actually get a set of declared constructors, so as an array, and it can even then it can pick up one of them and then it can use a constructor to create a new instance of a class. So these are different examples that I'm showing. This is how you can use this reflection mechanism. So how do you instantiate a particular object? For example, if you want to use a default constructor, you can say c.newInstance, then you will get an object. Non-default constructor, then you can basically do like this: constructor C equal to C.get constructor, and then basically you can actually get a particular constructor that you're looking for. Constructor C equal to well, there is a mistake here. It should be constructor C1, let us say, not C. So constructor C1 equal to C.get constructor, and then you pass an argument and then get C1, which is basically a constructor type, and then you say C1.newInstance, and then you pass the arguments, and then you get an object. Let's look at methods and members. C.get declared methods. This returns a set of methods that are declared for this class. Then find a specific method, like using getName and so on. Using getName and the parameter types, it can get a particular method m. You can invoke a method m.invoke class new object and so on. Then basically that particular method would be invoked. Then one can get different modifiers of a class. C.get modifiers. You can get fields, array of fields, C.get declared fields, or you can get a specific field. C.get field, you get a specific field f. Then you can do get and set. F.get, and it returns the value, or it can set f.set o.value, o comma value. So this value will be set into this object. So this is how one can use the reflection mechanism to basically get information about the base level application classes. We will also study the reflection in .NET framework. you will find that it is very similar to the Java. Now the .NET Runtime Assembly basically contains modules, and the modules consists of a set of classes. Using the reflection mechanism, one can perform the following, very similar to Java. Things like discovering classes in a module or methods. It can retrieve the name, parameter, access modifiers of a constructor, and it uses the class called constructor info for that purpose. The method info class will help you to retrieve the detail of a method for a given class. Field info class can help in retrieving the details of a class field. Now, as you can understand that with reflection, there are a lot of security issues that are possibly can get compromised. Both Java and .NET today addresses that. So .NET security essentially enforces rules that determine how much of type information as well as access types a reflection actually can discover. So for this purpose, it uses two classes. One is called the reflection pattern and security pattern. These are the two predefined classes that come with the .NET framework that can be used to control different access policies, access types that a reflection mechanism can discover. Now, if a client wants to use a reflection pattern to get details of another class, and suppose that those details are private. Suppose there are fields which are private, suppose there are methods that are private. Now, if that caller or if that client has the appropriate reflection permission, if that caller has appropriate reflection permission, I repeat that, if it has, only then .NET will allow the caller to retrieve those non-public information. If the permission is not there, the .NET framework will not allow. Likewise, the security permission is used during the object serialization, meaning that you want to serialize the information about the non-public attributes, non-public methods, then the appropriate security permission has to be there. So what are the overheads that are there if you are going to use reflection mechanism? While the benefits are obvious, that benefit is adaptability, flexibility. The code does not change even if certain structure changes. So while you have enormous amount of flexibility, you can really build a framework. I have given you examples like Tomcat, JUnit, etc. They all use this reflection mechanism for this purpose, but it definitely has different liabilities or the problems. One is the performance. Now, since the reflection resolves types dynamically, it actually involves extra amount of processing, like scanning to the it does some scanning to find the appropriate class. It does introspection to find out what are the methods that are there. That can definitely cause a slow performance. There are security restrictions that still might be compromised. Actually, reflection uses runtime permissions that might not be available. So what can happen is that while writing a program using reflection, you have possibly assumed that it is the caller can get all the structural detail of a particular class using the reflection mechanism. The caller can get information about the private members, private methods using the reflection mechanism. But at runtime, there might be a security manager which may not allow such information to be available. In that case, your application may fail because unless you have taken care of this situation, unless you have programmed it with the security manager in mind, unless you have handled that case, your application might crash. Now, while on the one hand the application can crash, on the other hand there are possibilities of a security breach if things are not designed properly. So because reflection allows one to access the part of the code that you were not supposed to access and start changing its values, this can actually really cause a security threat. In fact, it can also cause the application to crash. Now, you might argue that using security manager you can handle it, but what happens if the security manager is also not designed properly? If the security manager becomes default and then it allows everything to be accessed, if such a security manager is designed, then there will be a massive amount of security issues. So people who are writing reflection mechanism have got to be very, very careful that on one hand you need to write the reflection in such a way that it does not crash because of security manager. On the other hand, one has to design the security manager properly so that the information is not leaked to any caller. So reflection is quite difficult to understand and debug because things are all discovered at runtime. So by analyzing the code, it becomes really difficult to understand where is the problem. So compiler cannot detect such errors because the classes are not available. So it becomes really hard to maintain unless the code is poorly written using the reflection mechanism. Then there will be a lot more problems. Therefore, only experienced programmers should be able to use reflection properly. Most importantly, it is for an architect. As an architect, you need to give guidance to the design team that what part of the system should use reflection and what part of the system should not use reflection. Everything, you shouldn't allow every single thing to be written using reflection. Then there will be performance issues, maintenance cost, and so on. So with this reflection pattern, we basically come to an end to the architectural pattern, and let us look at a few closing notes, and we'll close with that. So we talked about patterns and tactics. So tactics are essentially the building blocks using which the patterns are created. Tactics are basically the solutions, remember. But these tactics are, again, since you have already gone through different types of tactics in earlier classes, you must have noticed that the tactics are basically general guidelines, the solution guidelines. But when you are actually implementing it, then tactics are the basic building blocks to actually define a pattern. Pattern is a very concrete solution. A pattern that does not have any tactic is really not useful. So here I have tried to basically map the tactic with the pattern and try to show the correlations. So in this table, the rows are different types of architectural patterns. We learned about layering, pipe and filter, blackboard architecture, broker pattern, MVC pattern, microkernel pattern, and reflection pattern. And the columns are essentially different types of tactics. In fact, those are different types of modifiability tactics. In fact, the kind of patterns that you have learned so far, most of them are actually modifiability tactics. So, but then you can argue that what about other tactics that like availability tactics, performance tactics? What about, let's say, the testability tactics, security tactics? Do we not have patterns for that? Of course you do have. For availability, of course there are patterns. For performance, of course there are patterns. Now, this is a really vast subject, and in fact, in my opinion, the patterns itself can be a subject, a complete subject. So we really have not covered all of them. We have basically covered those which are kind of very popular. At least these are the things that you must know. And those very popular patterns essentially deal with modifiability. So let's look at those. So the columns that I said are essentially different types of tactics, and these are a kind of many-to-many relationship, meaning that one pattern can influence, or one pattern can actually address more than one tactics. One tactic may use multiple types of patterns. So in modifiability, there are different tactics like increasing the semantic coherence, factor common services, generalize, maintain existing interface wrapper, resist communication path, use intermediaries all the time, use runtime registration, then defer binding and runtime binding. So let's look at these patterns and let's see how they influence these tactics. So layering definitely increases the semantic coherence. You are grouping the related modules into one layer. It can definitely factor common services because you know the base layer would basically be common services. It can also help in generalization. It can restrict communication path. Very clearly the calls are quite restricted. You are not supposed to call, skip the layers and so on. Then it uses intermediary. Sometimes there might be an intermediate layer through which you end up calling the base module. Pipe and filter also increases semantic coherence, and it also restricts the communication path. Blackboard architecture also kind of similar to layering. It increases the semantic coherence because here what happens is that you are having the blackboard in which the common data is there, and there are various modules which are actually kind of separate, and they are using this common blackboard to store, retrieve data. Blackboard can also help in factoring common services. It can generalize. Most importantly, it again restricts communication path. Those individual components are not interacting with each other. They only interact through the blackboard. It uses an intermediary, which is a blackboard. Broker pattern, again, is similar. It increases semantic coherence. It definitely factor common services. It can allow generalization. It restricts communication path. It uses intermediary. The broker itself is an intermediary. It uses runtime registration, and it also uses the runtime binding. The dynamic invocation interface is that. MVC pattern also restricts the communication path. It also implements the runtime binding. Microkernel definitely increases the semantic coherence, and it factors the common services. It also restricts the communication path, and it allows intermediary to actually access those internal servers. Then the reflection mechanism certainly increases the semantic coherence. So that's all for the reflection pattern, and that's the end of architectural pattern. Thank you.